Let's look now at section 2.4. Let's talk about linear equations and linear functions. So in the last section, we saw that functions are going to be objects that we're going to be studying in this course. And as you'll see as we go through this course, and for those of you who go into trigonometry and calculus and beyond, you'll note that functions become a very central part of the things that we study. But if we're going to be studying functions, we're going to start off with some of the nicer ones. So let's talk about a specific equation, which we'll then talk about in the context of a function. Let's begin with a definition. We're going to start off with a couple of constants. We're going to start off with a couple of just regular real numbers. So we're going to use the letters A, B, and C. Let A, B, and C represent real numbers. Let's let these be real numbers. Such that A and B are not zero. Such that A and B are not zero. Okay. Let X and Y be variables. Okay. Then the equation AX plus B, well, I guess I should write it this way. A linear equation, let me write that first, a linear equation in two variables is one of the type AX plus BY equals to C. So if you have an equation that is written as number X plus number Y equals number, so long as these numbers are not zero, that is a linear equation in two variables. Here we specify in two variables because in later courses, and in fact at the very end of this course, we may see some equations which are in three variables, an X, a Y, and a Z, or something like that. Right? But for now, we're going to stick entirely with linear equations in two variables. Now, when we say that you have an equation of this type, it doesn't necessarily mean it has to be written this way originally. So for example, 2x plus 3y equals to 6. That's a linear equation in two variables. Here your a is the number 2, your b is the number 3, and your c is the number 6. Now note, these numbers can be anything except for 0, which means they can be negative. So for example, if I have 2x minus 3y is equal to 12, for example, here, that doesn't violate anything. Yeah, I know that's a plus, but since that number could be a negative, we could say plus a negative number, or more simply, we can just say minus. So that also qualifies as a linear equation in two variables. You might also have your expressions strewn about a bit. So for example, you might have 2x equals to 24 plus 6y. And here, this looks a little different from this one, but you can rearrange things so that it looks like one of these. Here, we could subtract the 6y over this way, and this will give you 2x minus 6y is equal to 24. So even if your equation doesn't immediately start off looking like this, as long as you can reorder things a bit to make it look like this, that still qualifies as the linear equation in two variables. So the thing to watch out for when looking to see whether or not you have a linear equation in two variables is, do you have two variables, and do the variables not have any roots or any powers? Once you have an x squared, or a y to the third, or a square root of x, or a cube root of y, or anything like that, once you start having powers and roots, that'll no longer be a linear equation in two variables. But here, all of these have just two variables without any roots or any powers. And that's another good way to tell if you have a linear equation in two variables. Actually, as I'm looking at this, I realize I've omitted a word here. So such that a and b are not both 0. Here, it's okay if one of these is 0, just not both of them. So a linear equation, you can still have something like 2x is equal to 12. Here, your y would have a coefficient of 0. Right? You could even write 0y, although most of the time we don't. Or you could have your x have a coefficient of 0, and so your equation would look something like 3y is equal to 6. those would still be considered linear equations. And here, it's okay if one of these is equal to 0. Here, I was missing a word. They should not both be 0. It's okay if one of them is 0 at a time, but both of them shouldn't be. So let's go ahead and take a look at some more aspects of linear equations. First, let's go ahead and consider some graphs. There's a reason why we name these linear equations, and that's because of the way their graphs look. So let's go ahead and graph the equation 3x plus 4y is equal to 12. Whenever we graph a linear equation, in other words, an equation that fits into this category, the graph will always be a straight line. Once we know what the shape of a graph is, we don't need a lot more information to finish creating it. For example, if I didn't know anything about this graph, I could graph a few points and I wouldn't have any idea what to do with them. Maybe I'm supposed to pass through those with a straight line. Maybe I'm supposed to pass with a curved line. Maybe it's supposed to be sort of a zigzag line. I don't know. If I don't know the shape of this graph, I'm going to need a lot of points before I have an idea what the graph's supposed to look like. But when I do know what the graph's supposed to look like, I don't need a lot of information. For example, if I have these 3 dots and I tell you go ahead and graph a line through them, you have a lot of options. All right? You could have something like a V shape or a U shape. You could have something that's sort of an M shape. You have a circle, a diamond. There's lots of shapes that go through those 3 points. But once I tell you, the graph of this is supposed to look like the letter V. Oh, well, in that case, there's not really a lot of choices, are there? Something like that. So with a linear equation, if we didn't know ahead of time that it was supposed to be a straight line, we would probably need a good number of points before we could create that graph. But since we know it's going to be a straight line, you don't need a lot of information. In fact, all you need are 2 points. Because once you have 2 points, there is only one straight line which will cross through both of those points. Just like that. So here, when we're going to graph this, we only need 2 solutions. We can find more if we like, but it won't give us any more information than those 2 will, because every solution that we find will be on that straight line. So here, let's go ahead and find some solutions. Let's go ahead and let x equal to 0. We can choose any number we like and substitute in, but we may as well keep things simple. If I'm allowed to choose whatever number I like, I could choose 73. I could choose 1 over 612. I could choose pi divided by the square root of 4. But why not keep things simple? I'm going to use 0. I could also use 1 or -1. If I'm allowed to choose whatever I like, well, I like things that are simple. So here, let's let x equal to 0, which means that our equation is 3 times 0 plus 4y equals to 12. 3 times 0 is 0, so it can safely be ignored. This is now just 4y equals to 12. And if I divide both sides by 4, 12 divided by 4 will give me 3. And there we go. We have a solution. If x is equal to 0, y is equal to 3. In fact, I can even write that as an ordered pair, 0, 3. I can choose to plug in another number for x. I could say x is equal to 5, or 2, or really anything else I like. But I don't have to choose just for x. I could also plug in a number for y. Here, I'm going to choose something simple, in this case 0. And if I let y equal to 0, that's going to make my equation 3x plus 4 times 0 equals to 12. Here, 4 times 0 is 0, so we can ignore that. And that's just 3x equals 12. I can divide both sides by 3. That'll give me x equals 12 divided by 3 is just the number 4. So if x is equal to 4, y is equal to 3, and that's another point. Remember to keep them in order. X goes first, then y. So now if I'm going to graph these, I can go ahead and plot those points and draw my line. Let's see here. 1, 2, 3, 4, -1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, and 4. So if I have the point 0, 3, that's going to be this point up here. All right, 0, 3. And then 4, 0, that's 4 to the right, and then we don't move up or down at all. 4, 0. If I didn't know what the shape of this graph was, that wouldn't be enough information to tell me what it was. But since this is a linear equation, I know its graph is going to be a straight line. So those 2 points are all I really need. And there we go. This is the graph of our line. Graphs are useful because they help us find more information from just a little bit. What I mean by that is, okay, all I did to create this graph was just plot these 2 points. That was the only arithmetic, the only algebra that I did was with those numbers. Okay. Those 2 points have given me an entire line. On this line, we have a collection of other points. So here, that's a point, and every point represents an ordered pair. Notice right here, I have one particular point that I'm going to point out. Here, on my graph, I have the point 8, -3. It's a little bit hard to see because my drawing is freehand, which means it's slightly crooked. So here is a point 8, -3. Notice I never figured that point out, meaning I never did any algebra or any arithmetic. It's just some point that is on my graph. I could have picked this one over here, or really any of them. After all, there are points everywhere on this line. But I've gone ahead and picked this one because it uses a simple pair of numbers. And you say, okay, great. So what? You just pick the point out of the line. So what? Look what happens when I plug that point into my equation. If I come over here and say 3x plus 4y is equal to 12, look what happens when I plug in x is equal to 8 and y is equal to -3. Well, let's see. 3 times 8 rather is 24, plus 4 times -3 is -12, and 24 plus -12, in other words, 24 minus 12, that's 12. Oh, so if I plug in 8, -3, it gives me a true statement. But if you think back to our previous chapter, that means that by definition, this point is a solution to this equation. But notice, I never solved the equation using these numbers. I never did any algebra or even any arithmetic. This is just a point that happened to be on my line. That's what the point of a graph is. You can use just these 2 points. Notice, these are the only 2 that I ever actually went through and figured out. But by using those 2 points to create a graph, I have just found another solution. And in fact, another and another and another. If I took all of these points that are on this line, every single one of them will be a solution to that. Which means that by finding 2 solutions, we automatically get a bunch of other ones for free. Right? That's going to be one of the main points, the main attractions of creating a graph. It's going to give us basically free information. There is one more thing to note about this graph. When I chose numbers, when I chose this x value and this y value, I could choose any number I want. Like I said, I could choose x is equal to 55 or y is equal to 73 over 12. But I chose these numbers because they're simple to work with. In fact, 0 is such a simple number that we use it all the time. Because of that, these points right here have a name. Whenever you plug in x equals to 0, that gives you a point on the y-axis every time. This is called the y-intercept. The y-intercept is where the graph crosses the y-axis. And the way you find the y-intercept is by setting x equal to 0. Later on, when we have things that are no longer linear, this is still going to be the case. The y-intercept will still be wherever the graph crosses the y-axis, and you'll still find it by setting x equal to 0. Likewise, if we set y equal to 0, that's also an intercept, but instead of being on the y-axis, that's on the x-axis. So this is called the x-intercept, where the graph intercepts the x-axis. And you see right here, the way we find it is by setting y equal to 0. And later on, when this is no longer a linear equation in later sections and later chapters, this will still be true. You'll find the x-intercept by setting y equal to 0. And so go ahead and give this a try. Take the following linear equation, go ahead and graph it, and go ahead and label the x-intercept and the y-intercept. All right, let's have you try 3x minus 5y equals to 30. Go ahead and graph this thing and label the x and y intercepts. Go ahead and pause the video, give that a try, and once you're done, go ahead and unpause the video and we'll go through it together. All right, so let's take a look here. Since we're going to have to label the intercepts anyway, we may as well use those to create the graph. So the x-intercept, you find that by setting y equal to 0. Okay, so let's go ahead and do that. That's going to be 3x minus 5 times 0 equals 30. That's going to be 0, so really we're just left with 3x equals to 30. And if we divide both sides by 3, that'll get us x equals to 10. So when y is 0, x is 10. So our point is 10, 0. X goes first, then goes y. To find the y-intercept, we're going to do the same thing with the x variable. We're going to set x equal to 0, which is going to give us 3 times 0 minus 5 times y equals 30. Since 3 times 0 is 0, we don't worry about that anymore. And this just gives us minus 5y equals to 30. Dividing both sides by negative 5, 30 divided by a negative 5 is a negative 6. And so when x is equal to 0, y is equal to negative 6. And again, we put it in the order x, comma, y. All right, so there we go. We have the x-intercept and the y-intercept. So now we can graph and label those. All right, so we want 10, 0, which means 10 steps to the right, nothing up or down. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we go. And we have 0, negative 6, which is going to be down 1, 2, 3, 4, 5, 6 steps. Right there. We have 2 points, and now we can connect those 2 points to form the graph of this linear equation. And we can label these. This right here, this one's our y-intercept. You know that because that's where it crosses the y-axis. The y-intercept is given by 0, negative 6. And over here, this one's our x-intercept. You know that because that's where it crosses the x-axis. And the x-intercept is given by 10, 0. And there we go. When graphing a linear equation, there are going to be 2 special cases, and that is what happens when one of our coefficients is 0. In those cases, we end up with a much simpler looking line with a lot less information that we need. Let's say we were trying to graph x is equal to 3. Note, this isn't x plus 2y or x minus 5y, it's just x. Whenever you have a linear equation, x equals to 3, like this, the graph, well, the y variable is missing, which means we don't care what the y variable is. So one solution to this equation would be something like 1, 0. Oh, sorry, 3, 0. Because here the x variable is equal to 3. Now another solution to this equation would be, for example, 3, 1. Because again, x is equal to 3. And you say, well, what about y? Well, we don't care what y is. Here, y is 0, y is 1. It doesn't matter what y is. Y isn't part of this equation. So here, the solutions to this equation are any point where x is equal to 3 and y can be whatever we want. So if we graph an equation that looks like that, what do those points look like? Well, notice, this would not be a function. Here, we would have several points that have all the same first entries, all the same x values. And as we saw in our previous section, whenever you have something that's not a function, it's because these points are right on top of each other. If you graph that, that comes out to be a vertical line. Here, 3, 0, 3, 1, 3, negative 2. These points are all directly right on top of each other. So whenever you have a linear equation, x equals to a number, this will give you a vertical line. Every time. The only difference will be the position. Where is that vertical line? Here, over here, over here. On the other hand, if you have y equals to a number, let's say for example y equals to 2, the solutions to that would have any x value we want, but all the y values would always have to be 2. So solutions to this equation could look like negative 2 comma 2 and 0 comma 2 and positive 3 comma 2 and really any other point as long as the y value is equal to 2. Here, if we graph this, since the y values are always the same, negative 2 comma 2, 0 comma 2, 3 comma 2, notice all these points are directly across from each other. This will give you a horizontal line. Whenever you have x equals to something, that's a vertical line. Whenever you have y equals to something, that's a horizontal line. Every time. So these are special cases. These do still qualify as linear equations. And in fact, you notice the graph is still a straight line. It's just not a slanted line the way it usually is. Whenever we look at a line, we don't need a lot of information to graph a line. We just need 2 points. Well, another way we can say that is we can say we need a point to start from and another point to give us a direction. So when I say I can graph a line by graphing 2 points, another way I can say that is to say, starting from here, I want to go in that direction. I want to go that way. Okay. So how do I describe that way? You say, well, it's right there. You just drew it. Well, yeah, but we want to be able to quantify that. We want to be able to give a number or a variable or an equation, something that describes a direction. So here, whenever you're graphing something, it's going to appear on the XY plane. The XY plane doesn't really have a way of describing something happening diagonally, but it does have a natural way of describing things happening up and down or left and right. After all, on the XY plane, you have basically a ruler. This axis behaves as a way of measuring how far things are left or right. Over here, you have a number line along the y-axis, basically a ruler that helps you measure how far things up or down. So I can't really measure things diagonally, at least not in a natural way, not in an easy way. But diagonal can also be just thought of as a combination of left and right and up and down. So if I want to say, okay, I'm starting from this point and I want to go that way, well, that's hard because that's diagonal. For those of you who go on past college algebra and go into the next semester, trigonometry, we'll talk about how to do this with angles. But for now, we're not going to talk about angles. This is not trigonometry yet. So for us, we can describe it this way. We can say, okay, going diagonally, that's not a natural thing to describe on the XY plane. In trigonometry, you'll have other planes besides the XY plane, which will make things a little more natural. But on the XY plane, it is natural to talk about left and right versus up and down. And if you combine this motion to the right and this motion up, that does get you to this point just as well as moving diagonally would. So if we can talk about how far left and right we move versus how far up and down we move, that'll give us a sense of direction. That's called the slope of a line. So the slope of a line is given by the symbol m. Now before you ask, why is m slope? Should it be s? The answer is, I don't actually know. In fact, I don't think anyone knows. The letter m has been used for slope for hundreds upon hundreds of years. And it's one of those things that no one really ever wrote down why. It's just, that's the symbol somebody chose, and it's kind of stuck around for hundreds of years. Some theories suggest that m is the French for monter, which means to climb, like if you're climbing the side of a mountain. Other people say that M stands for modulus, which comes from another area of math, and that would kind of make sense, but kind of doesn't. And other people say, well, M is just the first letter of slope, obviously. That's meant as a joke, although it is a very old joke that appears in a lot of textbooks. In any event, it's a strange choice from our point of view, but that's just the way it is. M is the symbol that's used for slope. In any event, this M, this slope, describes this direction by breaking it down as a vertical and a horizontal motion. The way we do that is we say, well, okay, the vertical is simply given by the change in the y values. After all, this point right here would be something like x1 comma y1, and this point over here is something like x2 comma y2, right? x2 meaning the x value of point number 2, y2 meaning the y value of point number 2. Same thing over here. x1 is the x value of point number 1, and y1 is the y value of point number 1. So from the first point up to the second point. This is just the difference in the heights, the difference in the y values. After all, y tells you how far up or down you are. So here, if you take the difference in the y values, that tells you how far up or down you moved. For example, if this was 10 and this was 8, 10 minus 8 is 2. Oh yeah, well there's 2 steps between 8 and 10. This is the difference in the x values, just like this is the difference in the y values. So x2 minus x1. Slope is given by y2 minus y1 over x2 minus x1, just like that. And this is a way of describing this direction of the line. So when we say we can graph a line with 2 points, we can also graph a line using 1 point and a slope, because the slope will give you the direction just as well as the second point would. So, for example, let's go ahead and find the slope of the line that passes through the following points. In some examples, they'll give you a graph. They'll show you a picture. In other cases, they'll just tell you what the points are. It works the same either way. So let's find the slope of the line through the points, let's say -3 comma 2, and let's say 4 comma -5. You can tell I work really, really hard to come up with examples, right? 2, 3, 4, 5. Yeah. So in order to do this, we're going to take one of these points and designate it as point number 1. Right? We need to have one of the points be number 1. We need to have the other point be number 2. If we don't label them correctly, we're going to have these backwards, and that's going to give us a different answer. So you say, okay, well, so then how do I know which one's the first one and which one's the second one? It turns out not to matter. As long as you label one of them number 1 and label the other one number 2, you'll get an answer. If you switch them, that's fine too. If you call this one number 1 and this one number 2, that's also going to give you the same answer. What you don't want to do is you don't want to switch the answers halfway through the problem. What I mean by that is once you say this is point number 1, make sure it's point number 1 for the whole problem. Don't ever change it. Don't say, oh, this is point number 1, and then later start pretending this one's point number 1. So the choice doesn't matter, but you do have to make a choice, and you have to stick with that choice. Otherwise, you get the wrong answer. So here, I'm going to call this one point number 1, and I'll call this one point number 2. Okay? So now, the slope of that line is going to be given by y2 minus y1 over x2 minus x1. All right, y2 minus y1 over x2 minus x1. I'm going to fill in some blanks now. y2 means go to the second point and grab the y value. That's the second point. That's the y value. y1 means go to the first point and grab the y value. Well, that's the number 2. x2, from the second point, grab the x value. And x1 from the first point, grab the x value. And I'll simplify. -5 minus 2 is -7. 4 minus a minus, well, that's going to be a plus. 4 plus 3 is 7. And in that case, you can actually simplify that number. Negative 7 divided by 7, that's negative 1. And that's the slope of our line. This number quantifies the direction of your graph. So go ahead and give that a try. Go ahead and find the slope of the line that passes through the point, say 2 comma negative 5 and I don't know, let's go with negative 3 comma 3. Let's try that one. Okay. So go ahead and find the slope of the line that passes through there. Go ahead and choose one of these to be point number 1 and then choose the other one to be point number 2. If you like, you can even switch that. You can say, okay, let me do it once with this being number 1 and this being number 2, and then do it again with this number 1 and this number 2. You'll get the same answer either way. So go ahead and find the slope of that line that passes through those 2 points. Go ahead and pause the video and go through that. And once you have an answer, go ahead and unpause and we'll go through it together. Okay, so the slope of a line is given by y2 minus y1 over x2 minus x1. And I can fill those numbers in as long as I make a choice for point number 1 and point number 2. Here I'll call this point number 1, and I'll call that point number 2. Okay. So let's see here. Y2, that's the number 3, minus Y1, that's negative 5. X2, that's negative 3. And X1, that's the number 2. So here, 3 minus a minus 5, that's 8. Negative 3 minus 2, that's negative 5. Over here, this reduced to give me just the number negative 1. Here, this one doesn't reduce. Okay, so we'll just leave it like that. One thing you do not want to do for slopes, don't use a decimal and don't use a mixed number. Don't say something like 1 3/5. You're going to want to leave it either as a whole number or as a fraction. And we'll see why that is here in just a moment when we start graphing using the slope. Do not write these as decimals and do not write these as mixed numbers, not because it would be wrong, but because in the next few problems you're going to find that that's just going to make everything harder for you. All right, so let's go ahead and use this concept to help us graph. All right, let's start off with a simple one where we're given everything that we could possibly need. And then we'll get one that's slightly more complicated where we're going to have to find some stuff. Let's go ahead and graph the line that passes through the point 1 comma 3 with a slope m equals to negative 2 over 5. Okay. So this gives us a point on our line. That's where we're going to want to start from. The slope will give us a direction, and that will tell us which way to go. All right. So let's start off with a plane, an XY plane here. All right, 1 comma 3. So that's a point on my line, so I'm going to start from there. Now our slope, notice the numerator of your slope tells you the difference in the y values. Or in other words, it tells you how far up or down to go. Note that if that numerator is a positive number, that means you're going up. If the numerator is a negative number, that tells you you're going down. So right here, this will tell you up or down, where, as usual, positive is up and negative is down. Your denominator, well, that's the difference in the x values. Or in other words, that's how far left and right you're moving. So your denominator will tell you right and left. And again, as usual, right is positive, left is negative. All right, so looking at this, the numerator is a negative 2. Since it's a negative, I'm going to go down. 2 tells me to go down 2 steps. So right here, from this point, I'm going to go down 1, 2 steps. And then this bottom number, notice that's a positive. The negative's up here. That's a positive 5. So I'm going to move to the right 5 steps. So that'll be 1, 2, 3, 4, and 5. So that'll put me over here at the point 1, 6. Oh, I have that backwards, don't I? 6, 1. There we go. This is the point 1, 3. But now we have 2 points that both are on my graph. And since this is a linear equation, I can graph by drawing a straight line through those 2 points. Don't start and end at the points. The graph should continue on forever in both directions. So don't just say, oh, it's going to start here, end here, and that's it, I'm done. It goes on through forever. And there we go. We can graph a line if we have 2 points that are on the line, but we can also graph if we have 1 point on the line and the slope, which gives us a direction. So go ahead and give that a try. Go ahead and graph the line that passes through the point, let's do -1, 3 with a slope m equals to 5/4. All right, pause the video, go ahead and give that a try. Once you have a graph, unpause and we'll do it together. All right, so we're going to start off at a point, -1, 3, 1 to the left, down by 3. All right, -1, 3. And now our slope, this top number tells you you're either going up or down. And this bottom number tells you how much you're going either right or left. That top number is a positive, so you're going up, and it's a 5, so you're going to go up 5 steps. So from this point down here, you're going to go up 1, 2, 3, 4, 5. Oh, but you're not done yet, because now the bottom number is telling you that since that's a positive, you're going to go right by 4. So now we're going to go right 1, 2, 3, 4. So now we're at the point 3, 2. You might be asking, how are you getting that point? I'm just counting. I started down here. Notice my y value was -3. I made a mistake here. Let me go ahead and let me fix that. I graphed -1, -3. It should be -1, 3. So let's go ahead and do that correctly. -1, 3 should be 1 to the left and up 1, 2, 3. There we go, much better. That's our point -1, 3. I thought it was -1, -3 for a second. All right, so now we're going to go up 5 steps from here. So it's going to go up 1, 2, 3, 4, 5. And then I'm going to go to the right by 4 steps. So that's going to be 1, 2, 3, 4. All right, there we go. So I've gone up 1, 2, 3, 4, 5 steps. Notice my original y value was 3, but I've gone up 5 more. So 3 plus 5, that'll give me a y value of 8. Here, my x value was -1, but I've gone to the right by 4. So that's going to be -1, 0, 1, 2, 3. So here, there's no special trick or special secret to finding this point. I'm literally just counting. I'm saying I'm going to go up and I'm going to go to the right. So now I have 2 points that are on my graph. So I now connect, and there's my graph. And there we go. Now here, we're given a point and we're given a slope. But what if we're not? What if we're just given an equation? Well, as long as we know how to handle the equation will tell us this information. So for example, I want to go ahead and graph the equation 2x plus 3y is equal to 9. Okay. Now, we've seen before that one option to graphing this is we can just find solutions. We can set x equal to 0, solve for y. We can set x equals to 1, solve for y. Whatever we like. We can choose some points. We can choose some numbers, plug them in, find some points, and get our result. But another way we can do that is, let's rewrite this by solving for y. Here, let me go ahead and subtract the 2x from both sides. That's gone. And that'll give me 3y is equal to negative 2x. That's a positive 9, so I'm going to write plus 9. And then I can divide both sides by 3 all the way across to give us y equals negative 2/3 x plus, here 9 over 3 is just the number 3. Okay. Note that this is a function. As we've seen in a previous section, if we can isolate our y variable, this tells us that y is a function of x. So here we can rewrite it as a function. F of x equals negative 2/3 x plus 3. Whenever you have a function like this, where you've isolated y from a linear equation, and that works out to y equals a number x plus or minus a number, this is called a linear function. We're not original when it comes to naming stuff. If you have a linear equation that you write as a function, well, it's called a linear function. Later on, you'll have things called quadratic equations. And if you can write those as functions, those are called quadratic functions, and so forth and so on. All right? So here, whenever you have a linear function, first of all, it is a function, which means we do inherit some of the notation and some of the language from before, including how we evaluate, how we plug things in. But whenever we have a linear function, another thing to note is that this number here, the coefficient in front of your x, this is going to be the slope of the graph. The other thing to note is that if you substitute in x is equal to 0, anything times 0 will be 0. 0 plus some number will leave you just that number. So if you plug in x is equal to 0, or in other words, if you find f of 0, it's always going to give you just that number. But as we've seen before, whenever we find a point by substituting in x equals to 0, that's called the y-intercept. So what that tells us is that, well, here, if I plug in 0, it's going to give me just that number. Well, then 0 comma that number right there will give me the y-intercept. Like that. So in this case, if I was going to graph, that means that I wasn't given this information, but by solving for y and writing it as a linear function, I get that information. I know a point on my graph, namely that point will be 0 comma that number, and I know my slope. Okay, so here we go. I have the point 0 comma that number, in this case it's going to be 0 comma 3, and I'm going to have a slope of negative 2 over 3. All right, so now we can graph that. 0 comma 3, that's going to be 3 steps up from the origin. Let me label that 0 comma 3. That is the y-intercept. Now my slope, negative 2/3. That top number is telling me to go either up or down. Since that's a negative, it's telling me to go down 2 steps. So from here, I'm going to go down 1, 2. And then the denominator is a positive 3. So it's telling me to go to the right 1, 2, 3. So that's going to be the point 3 comma 1. Again, I just counted down and then counted across. And now I can go ahead and connect those points to find the graph of my equation. And there we go. We can graph. We can either do it by finding individual points, connecting those, Or if we write our equation in this form, then we can write the slope and the y-intercept and use those to create our graph. Whenever we have a linear function that's written this way, this form here is called a linear function. But if you don't write it using the f of x notation, if you just write it as y equals this is called the slope-intercept form. And it's called that for the obvious reason. If you write it this way, one of the numbers tells you the slope, and the other one will tell you the y-intercept, the slope and the intercept. So we call it the slope-intercept form. In algebra, we don't really name things in a mysterious or unusual way. We name it in what is the most straightforward way possible. If something's called the slope-intercept form, it's because it's the form that tells you a slope and an intercept. If something's called linear, it's because it's a line. Things like that. Slope-intercept form. Why? Because that's the form of the equation that gives you the slope and the intercept. In this case, the y-intercept. So go ahead and give that a try. Take the following equation, write it in slope-intercept form. If you write it in function notation or not, that's okay. Either one's fine. Here, it's okay if you just get up to the slope-intercept form. You don't really have to write it as a linear function. So go ahead and give that a try. Graph the equation 3x minus 5y equals to, let's say, 20 by writing in slope-intercept form. All right. Go ahead and pause the video, give that a try, and once you have written in slope-intercept form and graphed the equation, go ahead and unpause and we'll go through it together. All right, so we're going to start off with 3x minus 5y equals to 20. That was I'm just rewriting the original equation. And now I want to solve for y. So minus 3x from both sides. That's going to give me minus 5y equals minus 3x plus 20. And then I'm going to divide everything by a negative 5. Negative 5, negative 5. So that's going to give me a y. Double negative makes that a positive, 3 over 5. Don't forget your variable x. And 20 divided by negative 5 is negative 4. Okay, just like that. So now we have that our y-intercept will be 0 comma that number. 0 comma negative 4 is the y-intercept. The slope is going to be the coefficient of x. In other words, the slope is going to be 3 over 5. Notice both negatives divided away, so here that's a positive. And now we can graph. Okay. 0 comma negative 4 is the y-intercept. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. One word of warning here. Remember, the intercept is a point. You can't say negative 4 is the y-intercept. That doesn't make any sense. An intercept is either going to be 0 comma something or something comma 0. All right? An intercept is where is the point where your graph crosses either the x-intercept or the y-intercept. Points are made up as ordered pairs, not individual numbers. The other reason you don't want to call it a single number is because, well, with a single number, you're not really sure where on the graph it belongs. For example, if I say graph negative 4, well, I don't know which one. Is it negative 1, negative 2, negative 3, negative 4? Is it that one? Or is it negative 1, negative 2, negative 3, negative 4? Is it that one? All right, if I just say negative 4, there's 2 places I might be able to put it. And that means that I don't exactly know what I'm doing. So here, make sure that this intercept, you don't call it as a number, it's written as a point. So 0 comma negative 4 is my y-intercept. 1, 2, 3, that's 0 comma negative 4. And now I have a slope of 3/5. So that 3 is telling me to go up, since it's positive. That 5 is telling me to go right. Again, it's positive. So from here I go up 1, 2, 3, and then right 1, 2, 3, 4, and 5. So that'll give me the point 5 comma negative 1. And now I have 2 points that are on my graph, which means I can connect my dots with a straight line to graph my linear equation. And that makes us happy. For the sake of thoroughness, let's summarize all of the terms that we've seen so far. We've seen a linear equation, but we've seen it written a few ways. We have ax plus by equals to c. That's a linear equation. But we can also write a linear equation by isolating our y. And that ends up looking like y equals our slope times x plus some other number. Y equals mx plus b. This and this are both linear equations. But this is called the standard form of a linear equation, whereas this one we saw a moment ago is the slope-intercept form. Of the equation. They both have the same information, but in a different form. They're going to look a little different, and they're going to be a little easier or a little harder to work with depending on our context. It's not that one of these is better than the other. This one is best suited for graphing. You'll see in later sections when we get to chapter 5 and 6 that this form is actually better suited for working with algebra and in particular working with systems of equations. We'll talk about that later. So it's not that one of these is better than the other. They just both have different uses. If we take something that's in slope-intercept form and we write it in the function notation, instead of writing y equals mx plus b, we write f of x equals mx plus b. That is also giving us the same information, but now in functional notation, this is called a linear function. Like that. Note that the slope can be any number, and that includes 0. So there is a special case of the linear equation where f of x is equal to just b. Because here, if m is equal to 0, anything times 0 is 0, and that just leaves us that constant. So here, this is called a constant function. It's a function that has no variable, just the constant. And this is what happens whenever the slope is equal to 0. Okay. So this summarizes the different forms that we've seen. Our slope can be 0, but it's usually not. Usually it's going to be positive or it's going to be negative. What the slope gives you is a direction. If you have a slope that is positive, and it's a very small number, let's say 1/4, then your graph is going to have a positive slope, which means that it's going to move from lower left to upper right. With a small number, that means it's going to go up very, very slowly, though. When we say up, we mean from left to right, right? I could say, okay, that's going up, or I could say it's going down. Yeah, but when we talk about slope, we always go from left to right. So here this is from left to right, it's going up. But it's going up very slowly, hence the small number. On the other hand, if I have a large number that's positive, it's still going to be going up left to right, but it's going to be going up very quickly. It's going to be very steep. So in a positive slope, your graph is going up. For a negative slope, it's going to be going down. And again, depending on the size of the number, it's going to be going down very quickly. Here, -4, that's going to be going down very quickly. Or if it's a negative number with a much smaller size, that's going to be going down, but a lot more slowly. Something like that. If your slope happens to be 0, well, that means your graph doesn't go up or down. Or in other words, you have a flat line. So if you have a slope m equals to 0, that is a perfectly horizontal line. We saw that already. That's the graph of an equation y equals to a number. Oh, sure, y equals to a number. Or in other words, f of x equals to a number. Yeah, we've seen that before, but with y equals, not f of x equals. And finally, there is one last strange case, and that's what happens when your function's slope is undefined. You say, undefined? How does that work? Well, remember, the slope is a fraction. And with a fraction, you can have any number you want on top, and you can have almost any number on the bottom, except for 0. If you divide by 0, the whole thing's undefined. So that's what that means. If your denominator is 0, your slope is undefined. So here, slope is undefined. Or in other words, the denominator of your slope was 0. And the way that one's going to look is a vertical line. And again, we've seen that. That's what we get whenever we have x equals to something. And that's it. That summarizes all of the possibilities. And it brings us to the end of our section. If anybody has any questions, comments, problems, please make a note of them, write them down. You can ask me next time we meet, or you can send me an email. You know how to reach me, and I hope everyone has a nice day.